Hello everyone, my name is Juan Jimenez. Welcome to my video on the anatomy of the ulna. The ulna is one of the two long bones in the forearm, working alongside the radius to enable movement and provide stability to the upper limb. Its unique structure supports a wide range of motions, from lifting to rotating, making it essential for daily activities and clinical practice. In this video, we will explore the ulna in detail, starting with its location, size, shape, and dimensions. We will examine its surface anatomy, key landmarks, and structural features. We will also cover its divisions, composition, and relationships with surrounding structures like muscles and ligaments. Additionally, we will discuss its microscopic anatomy, developmental variants, common injuries, and clinical significance. By the end, you will have a comprehensive understanding of the ulna and its vital role in the human body. The ulna, one of the two long bones in your forearm, sits on the medial side, running parallel to its partner, the radius. It's the longer of the pair, stretching about 254 millimeters in adults, roughly around 10 inches. This slender bone has a gentle curve with a proximal dorsal angulation of about 6.4 degrees and a varus angulation of 12.4 degrees, giving the forearm its distinctive shape and aiding its flexibility for movements like rotation. In cross-section, the ulna shaft is triangular, providing strength in the attachment points for muscles. It tapers gracefully towards the wrist, where it's a round head that supports wrist motion. This unique structure not only stabilizes the forearm, but also enables the smooth coordination we rely on for everyday tasks, from writing to lifting. Let's explore the surface anatomy and landmarks and features of the ulna now. They are critical for understanding its role in the forearm. The ulna has several prominent features and landmarks that you can feel under the skin. At the proximal end, the olecranon process forms the bony tip of your elbow, easily felt when you bend your arm. Just below it, the coronoid process projects forward, interlocking with the humerus to stabilize the elbow joint during movement. The ulna shaft, or body, is long and slender, with three distinct borders: the interior, the posterior, and the interosseous. The posterior border is especially notable because it is subcutaneous, meaning you can trace it along the forearm's length with your fingers. Distally at the wrist, the ulnar head forms a rounded prominence, while the delicate styloid process extends downward. Both easily palpable, these landmarks not only define the ulna's structure but also serve as key reference points for clinicians assessing forearm anatomy and diagnosing injuries. Now, let's dive into the parts, divisions, layers, and composition of the ulna, a vital bone in the forearm. The ulna is divided into three major regions: the proximal end, the shaft, and the distal end. The proximal end includes the olecranon, which forms the elbow's point, the coronoid process, which anchors muscles, the trochlear notch, which articulates with the humerus for elbow movement, and the radial notch, which connects to the radius. The shaft or body is the long central portion providing structural support and attachment points for muscles. At the distal end, the ulnar head forms a prominence at the wrist, while the styloid process extends as a slender projection. Structurally, the ulna consists of dense cortical bone on the outer layer for strength and spongy cancellous bone inside for flexibility. A medullary canal runs through the shaft housing bone marrow. The periosteum, a thin membrane, envelopes the bone's outer surface, supporting growth, repair, and nutrient delivery, which is essential for the ulna's function. Continuing, we will examine the boundaries and relations of the ulna, which define its interactions with neighboring structures in the forearm. Proximally, the ulna articulates with the humerus at the elbow joint, specifically through the trochlear notch, enabling flexion and extension movements critical for arm function. It also connects with the radius at the proximal radial ulnar joint, allowing forearm rotation for actions like turning a doorknob. Distally, the ulna forms the distal radial ulnar joint with the radius, facilitating wrist rotation. An articular disc at the wrist separates the ulna from the carpal bones, stabilizing the joint during hand movements. Medially, the ulna's posterior border is subcutaneous, meaning it lies just beneath the skin, easily felt along the forearm. Laterally, the interosseous membrane, a strong fibrous sheet, binds the ulna to the radius, distributing forces and coordinating forearm stability. These relationships ensure the ulna's critical role in supporting smooth, coordinated movements of the upper limb in daily activities. Let us explore the attached structures of the ulna, including muscles and ligaments that enable its critical functions in the forearm. Several key muscles anchor to the ulna, each contributing to specific movements. The triceps brachii attaches to the olecranon, powering elbow extension, like when you push a door. The brachialis inserting on the coronoid process aids in elbow flexion, essential for lifting objects. The pronator teres and pronator quadratus muscles, both attached to the ulna, drive forearm pronation, allowing you to turn your palm downward. The flexor carpi ulnaris and the flexor digitorum profundus connect to the ulna shaft and distal end, facilitating wrist flexion and finger movements, such as gripping. Ligamentous attachments provide vital stability. The ulnar collateral ligament, anchored at the elbow, reinforces the joint against excessive sideways stress, crucial in activities like throwing. At the wrist, the triangular fibrocartilage complex connects the ulna to the radius and carpal bones, stabilizing the distal radio-ulnar joint for smooth wrist rotation. These structures collectively ensure the ulna supports a wide range of upper limb motions. We are now going to examine the histology and microscopic anatomy of the ulna, revealing its intricate cellular structure. The ulna consists of two main types of bone tissue. The outer cortex is made out of dense, compact bone, providing strength to withstand mechanical stress. Within the medullar region contains spongy bone, with a lattice-like structure that reduces weight while maintaining support. The compact bone is organized into osteons, or Haversian systems, which are cylindrical units containing concentric layers of bone matrix called lamellae. At the center of each osteon, a Haversian canal houses blood vessels and nerves, ensuring nutrient delivery and waste removal to keep the bone alive. The periosteum, a thin membrane covering the ulna's outer surface, is rich in osteoblasts, cells responsible for bone growth and repair, especially after injury. Lining the medullary cavity is the endosteum, a delicate layer containing cells that regulate bone remodeling. These microscopic features collectively ensure the ulna's strength, flexibility, and ability to repair, supporting its critical role in forearm function. Let's explore the developmental variants of ulna, focusing on how it forms and potential anomalies. The ulna begins to develop early in life, ossifying from four distinct centers. The primary center in the shaft appears around 8 weeks of gestation, forming the bone's core. Two additional centers at the proximal end for the olecranon and coronoid process emerge later, while a single center at the distal end shapes the ulnar head and styloid process. These centers gradually fuse between ages 14 and 18, completing the ulna's growth in adolescence. However, developmental anomalies can occur. Hypoplasia, where the ulna is underdeveloped, or aplasia, where it fails to form entirely, may result from disruptions in epiphyseal growth plates, which are critical for bone elongation. Such variants can lead to reduced forearm length, impaired elbow or wrist mobility, and challenges in daily activities. Understanding these variations is vital for clinicians diagnosing congenital limb differences and planning treatments to optimize function. Let's discuss common injuries and fractures of the ulna, which can significantly affect forearm function. The ulna is prone to several types of fractures due to its role in supporting the arm. Shaft fractures, occurring along the ulna's long central portion, are often caused by direct blows or high-impact trauma, such as a fall onto an outstretched hand. Olecranon fractures, affecting the elbow's bony tip, typically result from a fall directly onto the elbow, leading to pain and limited arm extension. Montagia fractures are more complex, involving a proximal ulna fracture combined with dislocation of the radial head, often triggered by a twisting injury or severe impact. These injuries can destabilize the elbow joint, impairing movement and strength, and may cause complications like nerve or vessel damage. Precise anatomical restoration through casting surgery or immobilization is critical to restore full function and prevent long-term issues like stiffness or arthritis, ensuring the ulna supports daily activities effectively. Let's conclude with the clinical and forensic correlations of the ulna, highlighting its critical importance. Clinically, the ulna is essential for elbow and forearm stability, enabling smooth arm and wrist movements. Fractures such as those of the olecranon or shaft can lead to complications like non-union, where bones fail to heal, or nerve injuries causing loss of sensation or strength occur. Detailed knowledge of the ulna's anatomy guides surgical interventions such as precise fracture fixation using plates or screws, and informs the design of implants tailored to restore function. Forensically, the ulna provides valuable insights. Measurements of its length and robusticity aid in the estimating age and sex and skeletal remains, while fracture patterns help reconstruct trauma events in forensic investigations. Recent studies on nutrient foramina, which supply blood to the bone, and medullary canal dimensions enhance surgical planning and anthropological analysis, bridging medicine and forensics. Thank you for joining me in exploring the ulna's fascinating anatomy.